Okay, so I'm going to use the PCATP system um, to explain the couple reaction that I mentioned last time. Okay, this is a typical example of how couple reaction looks like, and this one occurs in the body like um, and this one occurs in the body. As a matter of fact, this is the fastest way of energy production in the body. Okay, this is the fastest mechanism by which the body is able to generate energy. And for those of you athletes, this is the part that you want to train if you are doing like sprinting, fast releasing energy process. This is the part that you train to, that you boost this part, because this um, even though this is the least energy system, and this one you can't have a whole, is the one it produces the least, but then is the quickest. Okay, the quickest. So if you by training so that you get this enough of this, you will be able to you have a quicker, it has a whole bunch of advantage. Okay, so in sprinting and um, um, those things that require immediate higher um, immediate source of energy, you train, you make sure that your system is um, ready for that. Your system has this kind of energy system. Okay. Anyway, so that is a little bit of it. And you see that there's also, I'll just leave it that you kind of see, but there's a lot of other things too that many of you and some others will see. But I don't want you to know all that if you don't have to know. Okay. You don't have to, but I want to use it to explain how couple reaction looks like. Okay, so we have the phosphocreatine molecule. So in couple reaction, like I said, there is two reactions occur at the same time, whereby one reaction releases energy, and then the energy that is released by the other, by one reaction, is absorbed by the other reaction, okay, to also form another product. So the energy, so there's both exothermic and endothermic reaction occurring at the same time. Okay, and so this is what exactly, this is a typical example of how it looks like. So we see the PC, which is phosphocreatine, then hydrolyzes or breaks down into the phosphate, monophosphate, and then the creatine, and energy is released. Okay, and you see that the phosphate, the adenosine diphosphate also combine with phosphate molecule, monophosphate, and then with the help of the enzyme ATP synthase, um, it will form ATP, adenosine triphosphate. But this reaction involve energy, so that's why it's plus. This is endothermic, and so in essence, this negative ion is the one that this is using, and so this will cancel this. Okay, that's what And the same with the reverse. The reverse process is also true. So in the reverse process, the ATP also hydrolyzes, okay, like this. But I did not repeat that, but it will do the same thing to get a negative. So the ATP will also break down into ADP and what? Phosphate mono and monophosphate ion. Monophosphate molecule. Okay. And so the phosphate will then the single phosphate will then combine with the adenosine diphosphate, okay, and to form back the what? To form back the ATP with the help of ATP synthesis. But so this is how it's also all going to look like if you put the two together. Okay, so now you have the ADP, which is adenosine diphosphate, plus the phosphocreatine on this side, and then we have the 8, which will what happened, because this is going to break down. It's going to break down to release the phosphate and energy. Okay, and the phosphate will combine with the ADP with the help of the energy release and ATP synthesis. Okay, so with the help of all those things, you can now form the what? ATP and free creatine, okay, molecules. The reverse is also true. So in the reverse process too, the ATP is also hydrolyzed. Okay, the ATP hydrolyzes, okay, into what? It hydrolyzes into ADP and P molecule. That's hydrolyzes into adenosine diphosphate and a single what? Phosphate molecule. So the single phosphate molecule or the monophosphate molecule then combine with the what? The creatine with the help of the energy that was released through the exothermic process from the hydrolysis of this one. Okay, then the phosphate, the monophosphate will combine with the creatine with the help of that energy and what? This enzyme, the phosphocreatine kinase. Okay, and then you now this will form the phosphocreatine molecule will form, and then the free adenosine diphosphate too will also form. So the reverse is true, and this is called couple reaction. Okay, this is a very good example of how couple reaction look like. Okay, so this is the question. What are some of the examples, some examples of metabolic couple reaction that you know? Okay, so leave that in the comment. Okay, all right, and I will see you in another video. I hope you enjoyed this.